Okay, ladies and gentlemen, welcome to the physics of Skittles. This is a Royal Skittles set. There's a lot of different versions of Skittles out there. The way this game works is we take one of these tops that you see right here. Hey, you wind a string around it, as you can see that I've done. You load it into the launching right here, pull the string, and shoots the top out into the area. The idea is to try to knock over these pins. So how does this game demonstrate Newton's three laws of motion? Well, obviously, we've got Newton's first law right here with all of our pins. They are objects at rest, and as you can see, they will remain at rest until they are acted upon by an outside unbalanced force. Interestingly, the top will also demonstrate Newton's first law. An object in motion will remain in motion. Once I get it spinning, it will continue to spin until it acts on something. Bounces against the wall, has enough friction to slow it down, hits enough things that it eventually will slow down. But otherwise, it's going to stay in motion until it is acted upon. So let's see how that works right now. A lot of motion. It's starting to take a little bit of friction. Hopefully it'll do something before it falls completely over. The only pin that was affected by the spinning top was the one that got hit by this. So the object that used to be at rest remained at rest until it was struck. So that's what we had right here. Let's try this again just to see if we can't get a little bit more action happening here. There we go. So, object at rest gets acted upon by an outside unbalanced force. We also have Newton's second law in action. Whenever the top strikes one of our pins, Newton's second law says a force is required to accelerate a mass. Well, it's not moving. The only way it will accelerate, i.e. get knocked down, is when some force, in this case the spinning top, acts upon it. Let's see if we got Newton's second law right now. Nope. Looks like we're just going to miss out on it. Hey, so that was also Newton's second law. Interestingly, Newton's second law can actually be witnessed when we launch the top. The top itself provides just a little bit of resistance, and then I use my muscular force to pull on the string. My muscular force pulls on the string, but the string applies what is called tensional force or tension force. The tension force, since it is wound around the top, basically gets transferred from a straight movement of my arm, so I'll be pulling straight with my arm, but it causes, because the string is wrapped around, the tension force turns that into a rotational force. Okay, and Newton's second law says that that is going to result in an acceleration, and sure enough, we have an acceleration. You're also seeing Newton's third law in action. Whenever the top strikes against something, you'll notice that it bounces away, hey, or it grinds. And actually what you also see is as the top is touching the ground, the variations in friction on the top center of gravity actually causes it to push against the ground and causes it to move. You see Newton's third law right there as it barely nips some of the pins as well. Hey, for every force, there's an equal and opposite force. So if it touches it really lightly, the inertia of the pin keeps it in the same spot. So two equal and opposite force, a light touch versus the light inertia of the top. And so we're seeing small amounts of action occurring as well. So Newton's third law is really active here in Skittles. It's demonstrated, again, for every force, there is an equal and opposite force. Hey, you can actually see that when we launch the top as well, because Newton's third law, again, for every force, there's an equal and opposite force. By pulling muscular force backwards, the top fires forwards, and that's because it has a resistance against the pull that I'm making on it. And so by pulling backwards, it causes the thing to go forwards. That's equal and opposite by definition. Okay, and we're seeing that pretty clearly. So Newton's first law in action, Newton's second law in action, and Newton's third law in action, all here in the game of Skittles. Make sure you create a diagram. Make sure you explain it in all three paragraphs to describe how this is happening And this is the physics of Skittles. And this one's not doing all that much. Kind of boring. Come on, Top. Do something. You're doing less than my students. Enjoy.